I'll wait till 11:05 like usual to start. But until then, here's an interesting story. In my townhome complex, there's this cat that just lives here. We have no idea who it belongs to. It's not ours. We used to think we knew who it belonged to, but that person moved, so it's just here. And recently, that cat will not go away. We have a small, very small backyard, 2 lawn chairs out there, and it just sits on our lawn chairs all the time now. Don't know why. One time last week, when I was, it's beautiful weather recently, just had my door open because great weather. And I'm on the first floor with I have the backyard door in my room, and the cat just walks in one time last week. Kind of annoying, had to yell at it to get out. Try not to be mean to the cat. And now all of a sudden, because the cat's around more, like my eyes are watery and itchy and red. I think I'm just now discovering that I'm allergic to cats. So there's that. Something else with me recently. I now have a girlfriend, which is pretty cool. It's going really well. It's been a little difficult having to do dating through Zoom, so that's been interesting. We actually started back in beginning of February, so that's pretty cool. Thank you, Ashley. Oh, something I mentioned to BC on Wednesday. I mean, we're all missing each other. I miss you guys. Y'all miss each other and me and the class, I'm sure. At least I think so. I mentioned to BC that hopefully when this is all over, maybe late June or July, we could meet up at Mod Pizza or Land of a Thousand Hills coffee shop, somewhere out in Cyprus, where y'all are, obviously, and just meet and greet and hang out. Me say bye to you one last time, since that may not happen. Okay, well, it is 11:05 and a lot of y'all are in here. It is recorded for the people who haven't joined us yet, and I can let people in as they join. Okay, I'm going to do this a little differently today. Let's see how it will work. So, share screen. Now let's not go there. Let's go here. My first slide. Yeah, that'll be annoying. I'll put it right there. Okay, so just to remind you of some exam info. If you want more information, they have lots of information at apcoronavirusupdates.collegeboard.org. Your test is Tuesday, May 12th at 1 p.m. If you can't make that or something bad happens during that, makeup is June 1st at 3 p.m. The test is online, 45-ish minutes. It's only for your response questions, and there's 2 of them. First one is 25 minutes for the 5-minute upload time, worth 60% of the test. The second one is 15 minutes with a 5-minute upload time, worth 40% of the exam. because of the scenario, it's obviously going to be open note, open book, calculator allowed but not required, because they can't take it away from you. But also, to be equitable to people who don't have calculators, it's not required. So if you have one, definitely would help, but not absolutely necessary. You could use your computer, tablet, or phone, like some of you have been doing with recent, with the Google Classroom assignments or with AP Classroom stuff. Like you could do your work on your own sheet of paper and then take pictures and upload the pictures. That may be the easiest way for you to do it. There would be time for you to print off, write down, and then take pictures of that. But their software system is also able that you could like type your answers as well. And they got like math software in that, so you could write that with math terminology and notation. I think within 2 weeks prior to the exam, they have said that their system will be open so that people could practice how they would use it. But we'll get more information as later about that. But they want to give people time and the availability to be able to practice using it. Okay, well, so that's just some announcements. If you recognize this information from somewhere, I just copied the slide that they're using at the AP Live review videos from that YouTube channel that I shared with you. Hopefully you've watched some of those. They are very helpful. Okay, well, let's go into the humongous review sheet. So, Unit 5, starting with mean value theorem. Mean value theorem has blue. Okay. Mean value theorem is essentially saying that in an interval, the average rate of change is going to at some point to be equal to the instantaneous rate of change. The average rate of change, which means slope over the interval, will be equal to the instantaneous rate of change. So, well, this is going to be difficult to write on. Maybe this was not a good idea. If f is continuous and differentiable, if f is continuous and differentiable, then f prime of c will equal f of b minus f of a over b minus a. And so f of b minus f of a over b minus a is essentially slope. That's slope over the entire interval, the interval from a to b, or also called the average rate of change. So the average rate of change over the interval, we just connect a line from the beginning point to the ending point. That slope of that secant line would be equal to the instantaneous rate of change at some point. And given time, I want to go over one of the free response questions from your assignment for next week. And so we'll see. Actually, no, that's not on that one. We'll see some of the other stuff there, though. Rolle's theorem is just a special case of mean value theorem, where it's still going to be continuous and differentiable. So if continuous and differentiable, and f of a equals f of b. So if it's continuous and differentiable and f of a equals f of b, then, well, looking at the mean value theorem equation, if f of a equals f of b, we'd end up with 0 up there. So then that leads, just based on that equation, that f prime of c would equal 0 at some point in that interval. at some point in that interval. Okay. Extreme value theorem, just not formally, but just the essential idea of it is that if f is continuous, that should be the word on, not of. There we go, on. The interval a to b there will be an absolute max at some point and an absolute minimum at some point. And that absolute max or minimum could be at one of the relative maxes or mins, or it could be at one of the endpoints. It could either be at the relative maxes or mins, or it could be at the endpoints. Okay. Scroll down. Okay, and then just before is asking what are absolute maxes and mins, and for 4, 5, and 6, and a few of these others, I'm going to actually draw a picture. I'm going to say we have this picture. With, just to give a better example. So no, I don't. I want to move it. There we go. So my black dashed lines, those will be the endpoints of the interval. Add some points to this. Well, if we look at this endpoint, we got a very important point right here. We got an important point up here, one right there, and one at that endpoint. I'll just name them in order: A, then B, C, D, E. Okay, so the absolute max on an interval or forever. Sometimes you can be asked about the absolute maximum of something without an interval. But if you're given an interval, they're definitely asking absolute. So it's going to be just the highest point, whatever point is highest out of all of the other points. And so in this particular picture, we have that we can say it in words that f, we'll call that f of x, has absolute max of f of e equals e. That's one way that could be worded. The actual absolute maximum value is the function y value. The absolute maximum value is the function y value. So it is not point E. Point E is the x value where the absolute max occurs. And then what point is our absolute minimum here? What point's our absolute minimum here? Ideally, this is not just a video. You can unmute yourself and answer questions when I ask. Yes. Yes. Absolute. Yeah. So looking at my picture that I drew, the absolute lowest value occurs when x is b. The lowest value occurs when x is b. So I would call my absolute minimum value is f of b at x equals b. And yes, you can use the at symbol for the word at. That's acceptable everywhere, the whole world really. Okay. Then relative max and min. Relative max and min. Well, in this picture, we have B, C, and D are all where we have relative maxes and mins. B and D are both relative minimum values. C, we have a relative maximum value. E, at E, we already said we have an absolute maximum value. And so A is not really very important. A is just a generic minimum, a generic endpoint. And we'll talk more in the bottom half of the page about how to tell if something's a max or a min. Okay, number 6 is asking about critical points. Well, a critical point is one where so x equals c. We usually called it a critical value in our class. So x equals c is critical value if f prime of c equals 0 or f prime of c does not exist. And a critical value, it could be many different things. It could end up being a maximum or a min, or it could end up being a point of inflection. It could end up being a vertical tangent line, something like that. Like if I have the picture. So right about here, we have a horizontal tangent. So that'd be a critical value, but it was decreasing, and then it continued decreasing. So that would just end up being a point of inflection. This point up here is critical value because it's got a horizontal tangent, and it'll end up being a relative maximum. I tried to draw a vertical tangent right there, and wasn't very successful, maybe. But that was also intended to be. That could also be, if it's a vertical tangent line, a critical value as well. Okay, rest of this page. Okay, number 7. What does f prime of x tell us about a function? And the sign of f prime. Well, the sign of f prime, if f prime of x is greater than 0, then f of x is increasing. If f prime of x is less than 0, then f of x is decreasing. That should be easily remembered. And if we're talking about particle motion, if we bring this into the particle motion idea, if your velocity, which is the derivative, is positive, then that means your particle is going in a positive direction. So either right or up, depending on the scenario. And if we again think of this particle motion, if your velocity is negative and it's going in a negative direction, so either left or down. So all this information applies to that as well. If f prime of x equals 0, then critical value and maybe max or min. Number 8 asks about first derivative test. This is the most common, easiest way to tell if something's a maximum or a min. That's what both the tests, first derivative test and second derivative test, they test to determine whether something is a relative max or relative minimum. So in the first derivative test, what Theodore? If at x equals c, f of x switches from positive to, I already used the positive symbol, so use negative, to negative, then relative what? Would that be a maximum or a minimum if we switch from positive to negative? Oh, I forgot one very important thing. F prime, that should say f prime of x. If f prime of x switches from positive to negative, then we have a relative max. At c. And then this same stuff still applies if at x equals c, f prime of x. I don't want to write switches again. Switches from, if we switch from negative to positive, then relative minimum. Let's see. So that's first derivative test. Signs of f double prime. If f double prime of x are positive, concave up. F double prime of x negative, concave down. Hopefully you already know almost all of this that I am doing. Inflection point is a point where where f of x changes concavity. And this does ask for an example, so I can do one example for the two of them here. So if we look at something like this point right, I was concave up, and then we switched to concave down. So this point right here where it switches concavity is my point of inflection. So this region here, it's concave up, and we switch concavity to concave down, point where it switches point of inflection. Okay, 11 asks about second derivative test. And that is that first, if f prime of c equals 0. So if you already know that something's a critical value, if f prime c equals 0, you already know it's a critical value, then two possibilities. Then if f double prime of c is positive, well, that means it's concave up. And if it's concave up, it would look like a cup, causing it to be a relative minimum. Another possibility if f double prime of c is negative. That would cause it to look like frown, making it concave down, and it would be a relative max. Optimization problems. I do not have enough room here to fully go over these steps and how to recognize it. I'd say look at your notes, and as we get to some in the free response questions, I'll end up showing some examples of that. Okay, Unit 6, next page. Well, first, Riemann sums in general. Riemann sums in general are summing. That should be an S. Sum in many let's do this rectangle areas. Under the function. So that's generally what a Riemann sum is doing. Some of the notation is that summation from I equals 1 to n, where n represents the number of rectangles or number of intervals that are being used of f of x sub I times delta x, where in this delta x represents the width of each rectangle and f of x sub I represents the height of the rectangle. So doing this one time represents the area of one rectangle, then you just keep doing it for however many rectangles you have. Delta x would generally stay the same, most likely stay the same each time. And the function value, which is the height of each rectangle, changes based on like what x you plug in. And the x you plug in depends on which type of Riemann sum you're doing, whether it's a right Riemann sum, left, or midpoint Riemann sum. Okay. Number 3 is asking about the exact area. Well, the exact area, well, we would take our Riemann sum, and a Riemann sum is just an approximation. It is an estimate. If we have some finite number of rectangles, there's no way the Riemann sum is going to give the exact area underneath that function. But if we take infinitely many rectangles, then that will end up being the exact area. So the exact area is that the limit as n approaches infinity of summation from I equals 1 to n of f of x of I times delta x, where delta x equals b minus a over n. So this is a limit Riemann sum, which would give the exact area, which also equals what a definite integral is. The integral from a to b of f of x dx. First fundamental theorem of calculus. That is that given that capital F prime of x equals lowercase f of x, then the integral from a to b of f of x dx equals the antiderivative at b minus the, let me make sure that looks like a capital F, antiderivative at a. And then the second fundamental theorem of calculus is that if we take the derivative of an integral from a to x, of f of t dt. Well, the derivative of an integral is just going to give you itself, meaning the derivative with respect to x of the integral from a to x of f of t dt would just give you x. And then also, if there's something else up here at the x spot, other than just an x, then chain rule would be involved when you take the derivative, and you have to multiply by the derivative of that. Okay. I'm gonna move this real quick over there. On number 7, two very important properties we want to remember about definite integrals: that the integral from a to b of f can equal the negative integral from b to a of f. It's not formal notation, but just reminding you of that property, that if you flip the limits, you can flip the sign, and that works out. Also know that the integral from a to b of f plus the integral from b to c of f would equal the integral from a to c of f. So two important properties to remember. Next page. What's an indefinite integral? Well, an indefinite integral essentially is just one without the limits. That looks weird. There we go. That looks a little better. Of f of x dx, and all it equals is the antiderivative of a function. But since it's indefinite, we don't know what else could have been added. Can't forget your plus c. Power rule for integrals. That's an integral of x to the n power dx. That will be, well, the power is going to go up 1, so n 1 divided by the new power, n plus 1, and plus c. U substitution. I'll just show an example. If we are doing integral of x sine of x squared dx. Okay, well, we don't got a rule for that. We know how to undo x squared. We know how to undo sine, but we got them inside of each other. And so U substitution is essentially the reverse chain rule. And so we are going to call what is inside the parentheses u equals x squared, making du 2x dx. Okay. Now, how I normally did these problems was I saw that we were replacing what was inside the parentheses with u. And we want to replace anything that has to do with x. We want to replace anything that has to do with x. We're changing our variable to u now, meaning this x over here and this dx also need to be replaced. So if I can get x dx together by itself, then that would be helpful. And so I can do that here by dividing both sides by 2. So 1/2 du equals x dx, and for 1/2 du we'll replace x dx, and I'll just also pull that 1/2 out in front. 1/2 integral of sine of u du. And then the integral of sine is negative cosine. Yeah, integral of sine is negative cosine, so that'll be negative cosine, and then just plug the u back. So x squared. And can't forget the plus c. Okay, so that's all of the review sheets I was going to go over today. Yeah. anyone have any questions from the limits review or journey through calc? If you don't, I want to go over one of the free response questions that are on next week's assignment. But if you do have any questions, go over those.
Moon.
Peyton and Sarah, are you asking for B on journey through calc? And Casey, you want L. Okay. Did y'all need to be on the journey through calc? Is that what y'all were asking about?
That was
You can
whenever
turn off your mic and
we were
actually
trying to.
answer.
That was whenever we were answering one of your questions.
Oh, sorry. Oh, okay. I don't know why my sound was off. That's why I was confused. Oops. Okay, so L on journey through calc, and Peyton, you want 36 on the limits. Okay, we'll do 36 on limits first. That'll be easier for me to show. Okay. So 36 on the limits worksheet. Okay, so here is the limits worksheet. Let's go to draw. Green will be good. Okay, we're asked to classify the x values where f of x is not continuous, where f of x is not continuous. Well, on 36, anytime x is less than 2, we just have the linear function 2x minus 3. Well, that linear function itself will always be continuous because linear functions are. Between 2 and 4, we have the quadratic x squared minus x minus 1. That's quadratic. Quadratic functions in their domain are always continuous, and for x greater than or equal to 4, we have the horizontal line just 8. So that's also always going to be continuous. So the only places we need to concern ourselves with are where it changes functions, or where it changes. And one easy thing to note first is that, well, does h of 2 even exist? They never told us here that anything about h of 2. This says x is less than 2, x greater than 2, and less than 4. There's no point where x actually equals 2. So that is one place where f of x is not continuous, where the function is not continuous. It's not continuous. Not continuous at x equals 2 because h of 2 does not exist. Now, if we look at 4, we'll have to look at it a little closer. H of 4 does exist, and it is 8. So h of 4, and it's also 8 for any time after 4. So h of 4 also then equals the limit as x approaches 4 on the right of h of x, and both those things, the actual function and the limit on the right, equal 8. Okay. Well, then that right there, for it to be continuous at x equals 4, needs to also equal the limit on the left side. Needs to also equal the limit on the left side. So let's figure out what the limit on the left side is. Limit as x approaches 4 on the left Well, that's going to be the x squared minus x minus 1. So x squared minus x minus 1. We can just plug in 4 squared 16 minus 4, 12 minus 1. That equals 11. So the limit on the left side is 11. The limit on the right side and actually F4 is 8. So it is not continuous. So not continuous at x equals 4. Since limit as x approaches 4 on the left of h of x does not equal limit as x approaches 4 on the right of h of x. So that was 36 on the limits. Okay, then any other questions about the, so no longer L. Any other questions on the journey through calc or limits? Both keys are up. Both keys are up. They were up on Tuesday. And the keys for next week's assignment, I'll also post next Tuesday.
Where are they up?
On the calendar. Same place keys have been posted throughout the year on the calendar.
Calendar. Thanks.
Can you do W on the journey through calc?
Okay, W. Okay. Was there some part of the key that we did not understand on that one?
I just wanted to know, how do you get the critical values and why are you taking the integrals of them?
So to get the critical value is wherever we're asked to find the minimum value of f, the minimum of f. And so the critical value will be anytime f prime either equals 0 or is undefined. Well, they gave you what f prime is. They gave us on W that f prime is 1/4 times x plus 4 cubed. So they found the critical value by setting f prime, which was given, equal to 0. And that f prime, which was given, will equal 0 when x is -4. So x equals -4 was a critical value. And they also used the 2 endpoints. This, since there is an interval, this is essentially a absolute max or min kind of problem. Then the reason you did integration was they didn't give an actual f function. They didn't give an f function here. We don't know, like about f, we only have the f prime graph. For f, we only have the f prime graph. So we don't have some function to be able to plug in. If we're asked to find what is the minimum value of the function, I mean, actually, so you know what I'm talking about. Share my screen. Here we go. So on W, we're asked to find the minimum value of the function, which is asking for the minimum value, the minimum y function value. Well, if we had the actual function, we would then just plug in these critical values of -6, 2, and -4 into that original function to figure out what the absolute minimum value was. But we don't have a function. We only have a graph of f prime. So since we only have a graph of f prime, that's why we needed to do integration. So if we think about the first one that they did, when x equals -6, well, based on fundamental theorem of calculus, some future value will equal the original value plus the displacement there. Here I could write it a slightly different way. Because the integral from a to b of f prime of x dx, well, we would take the antiderivative of f prime, which would just give us f of x evaluated from a to b. And then we would plug those in, having f of b minus f of a. And that f of a could be added over to the other side. So it could also be called, I could rewrite this saying f of b equals f of a plus the integral from a to b of f prime of x dx. And that right there, this right here is essentially what they are doing to be able to solve that. They want to know what we want to know on that problem, what f of 6 is. We want to know what f of 6 is. And so, be more precise and show again. Oh, sorry, -6. We want to know what f of -6 is. And so if we want to know what f of -6 is, we could add the f of -2 and take the integral from -6 to -2. Well, that right there is subtracting. So it's just going the other way around, but it would still work, just going backwards. So then they did f of -2, yeah, plus the integral of f prime of x from -6 to -2. That should be a minus. So they're using the idea that the future value equals the beginning value plus the displacement. But for f of -6, it's actually the very beginning value, so it's backwards with that being a minus there. So that's why they were doing integration, because we don't have a function for f. If we had a function for f, then we could just plug it in to get the absolute max or absolute min. Okay. Well, I want to go on real quick and talk a little bit about one of the free response questions from that's on next week's assignment. It's a good review of a lot of topics. So on the 2016 question number 3. So in next week's assignment, you have the 2016 free response questions, and I said don't do question 5 because we never covered it, and it's not on the AP exam, that topic this year. And you also have another set of free response questions from a Brian Passwater, who makes great questions. Okay, well, on this one, question 3 from 2016, they gave us that the figure above is the graph of a piecewise linear function. No, move this. There we go, move that up there. Okay. From -4 to 12, the function g is defined as g of x equals the integral from 2 to x of f of t dt. Well, we're asked, does g have a relative min or relative max or neither at x equals 10? Okay, well, we want to figure out if something's a min or a max or neither at a specific value. Well, we just talked about that going through some of the Unit 5 stuff. We can use first derivative test for this. So we want to figure out at x equals 10, does g's derivative switch from positive to negative or negative to positive? Does g's derivative switch from positive to negative or negative to positive? Well, we got to figure out what g's derivative is then. Well, g's derivative, g prime of x. If we take the derivative of this accumulation area function, what are we going to get?
Just the original function of.
The original function f of x, yes. Which is awesome. And one cool thing about what I just wrote down on this, as I remember it correctly, I'll tell you, on this question, as long as this, what I just wrote, is written down somewhere, that was worth 1 point of the 9 points for this question. Just recognizing that the derivative of g is f of x. And because that's applying the fundamental theorem of calculus, which, I mean, there's no way that's not going to be on this year's tests. Now that it's even shorter, there's guaranteed. I mean, we're taking calculus, fundamental theorem is going to be on there somewhere. So we want to figure out, when does g's switch from positive to negative or negative to positive, or neither? Well, does it do that at x equals 10? Well, at x equals 10, this f right here, this is g prime, as already said. And at 10, it doesn't switch at all. Yes, at 10, x equals 0. I mean, the function equals 0, but it's negative on the left and negative on the right, so it does not switch signs. So we see there that g prime of x does not switch signs at x equals 10. So neither min or max. There's many different ways you can justify this. You could mention that it's negative on both sides, and that would be a correct justification. Several different ways you can justify that. I'm pretty sure that was also just only 1 point there. Then B asks, does the graph of G have a point of inflection at x equals 4? Does the graph of G have a point of inflection at x equals 4? Well, a point of inflection is when you change concavity. Okay, so we want to figure out, does it change from being concave up to concave down at that point? Well, it would be concave up if g double prime of x is positive, concave up, and if g double prime of x is negative, it would be concave down. Well, g double prime of x is f prime of x, meaning the slopes. So if we look at the left side of x equals 4, the slope is positive. The slope is positive. I could say f prime greater than 0 there, and f prime less than 0 there. A point of inflection, another thing to remember, point of inflection is where the derivative has a max or min. Point of inflection is where the derivative has a max or min. So yes, there is a point of inflection there. Yeah, because on the left side of x equals 4, f prime, which is g double prime, is positive, and on the right side, of x equals 4 of prime, which is g double prime, is negative. So it does switch from concave up to concave down for g there. And yes, at x equals 4, g of x changes concavity. Let's be more specific. Changes from concave up to concave down. Okay. And parts C and D of this question, and then we'll be done for the day. So, the graph and the question stem. Part C asks, well, what is the absolute minimum value and the absolute maximum value of G on the interval from -4 to 12? Okay, so an absolute min max problem. So in an absolute min or max problem, we need to figure out where critical values are, because the absolute min or max could occur at the critical values, because it could be at either the relative min or max, or our absolute min or max could occur at the endpoint. So we've got to check those as well. So where do we have critical values? Well, where do we have points that could be a min or max? We already said earlier that 10 is not a min or max. We already said earlier that when x is 10, that's not a min or max. So we don't need to think about that point. Are there any other points that could be a relative min or max? Any other points that switch from positive to negative or negative to positive? Because again, this f is g prime.
6 and -2.
Yes. 6 and -2. So those are both candidates for what could be an absolute min or max. So we will use both of those points. And then we also need to use the endpoints of -4 and 12. So we use all those 4 points. And I'm going to make myself a table. X and then g of x. So x, we'll just go from left to right, -4 first. So we want to figure out what is g of -4. Well, g of -4 would mean integral from 2 to -4 of f. Integral from 2 to -4 of f. Okay. Well, we just can do some geometry here. This triangle right here can cancel with this triangle right here. These two triangles I have in blue will cancel. They're both the same area. But then this triangle right here, that'll be involved, because we're going from 2 to -4. And this area right here, that'd be 2 times 4 divided by 2, which would be 4. We're going in the left direction, so that will be -4. Yeah. So that will be -4, because we're going in the left direction. Okay, now let's check the next point. The next point, as you said, was -2. -2. I don't know what that squiggle is, just squiggle it even more. So we're now going from so g of -2 would mean the integral from 2 to -2 of f. Okay, so we're just getting the area starting at 2, +2, and ending at -2. The area starting at +2, ending at -2. Well, that's that whole triangle, which would be 4 times 4 divided by 2, so 8, but we're going in the left direction, so that will be -8. And then the next important point, the critical value of when x is 6. So when x is 6, g of 6, that means integral from 2 to 6 of f. Integral from 2 to 6 of f is that same triangle, but we're going right, so now it's just going to be a positive 8. And then the last endpoint, g of 12, that means integral from 2 to 12 of f. Integral from 2 to 12 of f. Well, let's, I'm going to go with a different color real quick just to clarify things. We're going from 2 to 12, and this big triangle in purple at the top can cancel with this triangle right there. So the part from 2 to 12 that we care about is just this piece over here on the end, with that, which will be a -4. So when x is 12, g is -4. Okay, so now we can answer, now that we got that info, that g has absolute max of, the easiest way to give this answer is just to give the whole point like that. So our absolute max we see here is 8. And so I would say we have an absolute max of g of 6 equals 8. And absolute min of g of -2. That doesn't look like a -2. Just want it to be more clear what I'm writing. G of -2 equals -8. Okay. And then by the way, this part C was worth 4 points. Part C was worth 4 points. So if I go back real quick and tell you some other of that, just having this written down somewhere was worth 1 point. A was worth 1 point. B was worth 1 point. But both of those had to have the reason with it to even get the point. Both of those had to have the reason to get the point. So that's 3 right there. Part C was worth 4 points, so then that's 7, and part D was worth 2 points. Okay. In part D, we're asked, where is G negative? Where is G negative? Well, looking at some of the point values we already found, we see that at all the way at the left side, G of -4 is -4. Then it goes down to -8. Then it comes back up to +8. So somewhere between there, it switches. And to clarify when it switches, what would be G of 2? What would be G of 2? Come, it should be obvious. What is G of 2? G of 2 would mean the integral from 2 to 2. What happens if we take the integral from 2 to 2? We would get 0. Okay. So the G values were negative from -4 until when x is 2. So from -4 less than or equal to x less than or equal to 2. That's one interval when G is negative. And then it's positive because we know it was going up until at x equals 6, G was 8. And then that was a absolute max. Then it starts coming down. So sometime between x equals 6 and x equals 12, it crosses 0 again because at the end, when x is 12, G is -4. So when's the next time that G is 0? Well, as discussed when I found G of 12, this purple triangle here canceled with this purple triangle here. And if at g of 2, g is 0, g of 2 is 0, and then these two purple triangles cancel, g of 10 would also end up being 0. So then the last interval where g is negative is from 10 less than or equal to x less than or equal to 12. And just having both of those different intervals was the 2 different points, one for each interval. On C, the 4 different points were the 2 different answers of where the absolute max was, where the absolute min was, were each 1 point. 1 point was for considering the relative max and min of -2 and 6. Another point was for considering the endpoints. Well, that has been a long lesson now. We will meet again next Wednesday, and I'll answer any questions you have about next week's assignments, as well as go over Unit 7 from the review sheet. Okay, well, good to see you guys as always. Wish we could meet in person. This will be posted later. Have a great day.